Yeah, to be honest, like our projects are the chances of us going to prison, I think, like 1% of whenever we talk about privacy, people just think about tornado cash or private transfers, right? So privacy is something about users, like individuals or data, sometimes ideological, right? But I think confidentiality is about systems, like any kind of system that needs to have like data protected for the sake of the logic of the application, right?
Fairblock is a dynamic confidentiality network, and they encrypt blockchain transactions using MPCs, or multi-party computation. Today we're going to talk with the founder of Fairblock, Peyman, on how MPCs work, on the trade-off space and how they manage to make dynamic performant MPCs, why we need encryption and MPCs in the first place for voting, auctions, AI, and privacy, and tons of different use cases. So let's get to it. Can you explain Fairblock in the most simple, concise way, and then tell us sort of what you guys offer, the specific ecosystem, technology, and just give us a general overview so we can like plan the podcast to talk about all those details?
For sure. Yeah, so I'm happy to be here, and my name is Peyman. I'm a new founder of Fairblock. And Fairblock, in short terms, is like a dynamic confidentiality network. And the challenge that we are solving is that today's public blockchains are leaking your every message and every interaction that you have with applications are leaked publicly with everyone, right? So it limits a lot of applications, a lot of like it introduced a lot of challenges with the current infrastructure and mechanisms, like in DeFi or like for censorship or like front running issues. And it also limits like future applications, like even in future if you want to have like confidential AI, even voting on chain, and like even games like poker, we don't call it confidentiality in our real life, but everything like that needs to control the flow of sharing your information with other people in a multi-party setup is somehow confidentiality for us, right? So historically there's like a lot of projects working on that, and the problems that they have is either like regulations or like being isolated and like very painful for end users or like protocols to either plug it in or like use it, right? Because I call it isolated chains. You should migrate to another chain and then like install something and then learn something to use that. Whereas in Web2, in the normal internet and in our real lives, we don't like every time that we have privacy or confidentiality, we don't buy it, right? It's like already integrated in the background. And we just go to a website and the whole internet is already 95% encrypted. That's our vision for Web3, like to bring confidentiality and encryption in a very accessible and seamless way everywhere that it matters, and enable like expand the designer space from what we are trapped today with like meme coins infrastructure, and hopefully we can build the new internet really with real applications, serious applications in like next 5 years by like fixing one of the most fundamental issues.
Yeah, so you guys are applying encryption to not just one blockchain, but sort of, I guess, like as a service or like fitting them onto sort of any sort of committee. Is that basically a good way to think about it?
I think the good way to think about it is like what Vitalik recently described as like co-processors and glue. And I think so far we've seen a pattern in blockchains. Like for example, it started with oracles and Chainlink. We have cross-chain projects like Axelar, Wormhole, and we have things like Nobel. We have things um, like even EigenLayer, EigenDA, or like Celestia. And in all of these cases, I think the general pattern is that there are features, there are like fundamental issues with public blockchains in different cases, even like rollups. There is like some issues that it introduces the need for like some network. I call it like reviving networks because like they revive the like slow like bleeding public blockchains, and they have their own ecosystems. People can build on top of them. Maybe there's like some incentives that are cheaper, they're faster, but they also, I think the point here is that they are not selfish. They are not like asking everyone to bring your own application, your smart contract just inside my own blockchain, right? Like users can have like seamless access from the front ends of their favorite applications. Developers can plug it in the current blockchains, but they can also like bring it to the other blockchain if they want to remove the friction. So I think there is like flexibilities in the demands of the developers and the users, and I think as a like infrastructure project is like our responsibility to like being like whatever they like at least giving them the options to choose between these options, like different ways.
Mm-hmm. And so I guess could we go through those options? So do you guys have your own chain, or can you talk about sort of the integration you guys have, and then we'll talk about the technology part?
Yeah, for sure. So we have the chain. The name is Fairyring. So Fairyring is like a network of mushrooms, right? So we see blockchains as the mushrooms, and our name is Fairblock. So like the fairies and the mushrooms in the dark forest, that's where it comes from. And the reason that for having the blockchain itself is that for MPCs, we do require like a decentralized network of people communicating with each other in like a partial synchronous way, and also having economic security. So like we can't just simply have like a couple of our friends communicating with each other with NPCs. Like that's not like decent enough for Web3, right? For like financial applications. So the reason that like in the first place we had like a chain and is that like economic security, the communication layer, and also using like some like cutting edge technologies like IBC or like ABCI plus plus or even like with TEEs. These are just like much easier to like integrate and be composable with other parts of the blockchain industry. And for like so like we have a chain. I call it dynamic confidentiality network because we are dynamic. We can provide like optimized MPC networks, MPC solutions for each application. I can touch on that later.
Oh yeah.
Basically, it's like an orchestration layer to allocating like tasks, applications to each of our clusters for that are running different MPC algorithms. And by MPC, I mean encryption, not just like signatures or like wallets and like this kind of applications that we've seen so far. So basically, we can have our own applications in our chain, in our own network, but like we can also export it to other blockchains and have like a much higher like surface of like service.
Oh yeah. So I guess did the blockchain come first, right? And then you guys decided to expand the services to other committees?
So like the blockchain itself, it's like a committee, right? It has like some validators. So right now we are focused on like a very specific and optimized solution, MPC solution, that we believe that it solves like 90% of the applications without additional fancy cryptography or like other costs. But the same set can be used for running other MPC algorithms, right? So it's like a like same as like any other like network like eigenlayer or like Celestia or like Axelar. There is a validator set and they can work together on like different tasks for other chains or like our own like ecosystem.
So you guys are not applying encryption. You're applying the set. What do you call it?
Fairing.
Fairyring into other sort of blockchains, other sort of committees, rather than like copying the encryption and then like applying it to. So you're applying the committee itself to these other committees.
Mm-hmm. Yeah, so like the committee is in charge of like cryptographic operations like threshold decryption, like re-encryption, like computation over encrypted data. But like there is still the need for like other committees for consensus over like transactions, for like executing the logic of the transactions if it's not in our own blockchain, right? So maybe like it would be much more like simpler to explain it in an example, right? So like we have like voting, right, or like auctions everywhere, but the problem with some of them is that they are like open auctions, right? Open voting systems, and like they can be manipulated. Or even like when you're trading, people can see the details of your trades. So we want to encrypt them, right? So in all of these applications, we don't need to keep them encrypted forever. We encrypt them in the front end of the applications. It would be seamless, like Web2, like it's like a public key cryptography. We encrypt it over the deadline of these applications, and then there would be like encrypted transactions generated in the user's front end. So like there is no middleman here. It's not going through our chain. And then once the transaction is encrypted, it can be stored anywhere. Like it can be like in the block space and Arbitrum rollup. It can be in Osmosis encrypted block space, right? So once it's encrypted and included in the block space of other chains, or like if it's our own applications in our own chain, there is a need for decryption. So even if you are using like fancy cryptography schemes like FHE, even if you want to use like other MPC schemes, there is always a need for threshold decryption or like other cryptographic operations. So for those cryptographic operations, they will send a request to our chain, and we will take care of that, right? Because they're like either expensive or like technically impossible to do it other way, in other places. So in the case of like auctions or like votings, for example, the bids, the votes are encrypted, the trades are encrypted in other places. And when there is a need for decryption, they will send a simple request to us. We will decrypt it and send the decrypted results back to the other blockchain or the application. And they can aggregate the results and execute the logic of the application, right? So for in this case, like voting, like your votes are encrypted, other people cannot manipulate it during the voting period. And once it's finished, we can like decrypt it and like see like who is the, I don't know, who won the election, who won the like auction, right?
Yeah, so it's like encryption as a service, if that makes sense.
It's like if you describe like any like AVS as like a security as a service or like Celestia, like I don't know, data availability as a service, yes, but it's like
Okay, and so this Fairyring is a Cosmos SDK chain, is that right?
yes.
Okay, I guess we'll go into MPC. So could you describe how MPC works, and then just explain MPC and how Fairblock uses it?
Yeah, for sure. So MPC, like on the very high level, like there's always like some network of people, and each of them has like a secret share. So like nobody knows like the other secret share or like what's the root of that master secret key share. And the beauty of that is that people are working together to do some kind of cryptographic operations, right? So there is like two subsets. Like one more popular subset so far in crypto is like threshold signatures or like other kind of MPCs, specifically for wallets. So in this case, it's just like signatures, right? So people, like 3 out of 5 people or like 5 out of 5 people, they sign a transaction with each other. And in this case, the secret shares are their like partial signatures in a way, right?
Mm-hmm.
So like nobody can sign it just by themselves. But the reality is that in cryptography, like that's a very small subset of like MPCs. The like bigger part of MPCs is that people can work together to decrypt the transaction. So you can encrypt a transaction, you can either hold it or like even compute over that. And once like the computation is finished, you can decrypt it together. So the beauty here is that people can operate over encrypted transactions and nobody can see like what's inside it, but only after like there's like a need for decryption that we can decrypt the whole result, all of the transactions, like depending on the application, in a way that is only possible when like 2/3 of validators are working together to actually do that.
Yeah, and so Osmosis uses the threshold encryption, right?
No, actually, like Osmosis came up with the idea of threshold decryption, I think like 3-4 years ago, but
Oh, yeah.
just it was just an idea, right? I think it was good inspiration for us, but like we haven't seen like actual implementation yet, and I don't think they're going to do that. Like this is why we've been talking with Sunny and Dev like in Fairblock to actually do that. One of the good like that's like one of the inspirations for me that why we need another network, because like with Osmosis you need like with the original idea, right? You need to encrypt the transactions, and for each of the transactions, all of their like 200 validators should send a decryption share. So if you have 100 transactions and 200 validators, it would be like 200 times 100 partial decryption shares, right? Whereas in our case, since we are using identity-based encryption for this specific application, it's just one key for Osmosis, and there is only like 20 key shares, like number of our validators, or like maximum 100 shares in our chain, and then they will be aggregated quickly in our chain, and we will send it to Osmosis. So this is how we make it somehow like more scalable and like practical in a way, by abstracting away all of those computations and like overhead in the block space inside our own network.
Yeah, so you talked about it being optimized. So can you talk about, I guess you already did, on the efficiencies or like the slow parts of MPC and how you can't sort of uh have it for everything, and then how you guys
Mhm.
specifically optimize it, just like get more into those details.
Yeah. So NPCs, like a lot of people really want to call NPCs as NPC and like call it a day, but um, it's like consensus in like blockchains, right? There's like millions of ways to have like consensus, and like it's like an ongoing research area, and each of them has their own like trade-offs, and like some of them are for better for this application, some of them are for better for that application, and like none of them are free, like, right? So I made up the term of like UPS dilemma. So the U in the UPS dilemma is use cases, right? So if it's just like for signatures, so it's obviously better to like use like one of the things that we already have, right? If it's for like AI, we need like more fancy algorithms. If it's for like front-running protection, we need something much more simpler and lightweight, right? So that's like the U, right? Between the what you are solving, how much general purpose solution you want, and that's the U, and the P is performance, right? So what's the delay that you can actually tolerate, right? If you use like something like FHE, the delays are like pretty hard. Like it's like 100x to 1000x of like overhead, right? So it's not really the best way to solve simple applications like front-end protection, voting auctions. You don't really need this kind of heavy solutions. The way that I describe it is like opening a door with an axe. Yes, you can open the door with an axe, but it's harder. It takes a lot of energy, but it's also is very expensive. So that's like FHE. But in some cases, you do really need the axe, but not for like our day-to-day like applications today. And yeah, that's the P, so the performance, and the S. S is like security, right? So if it's like a game, if it's an auction for like simple applications, if it's like a simple like DeFi protocol, we don't need like billions of dollars of security, right? We already have like with like 20 validators, like 30 validators, we may have like much more like security than many Cosmos chains or like rollups, right? So we should be like realistic about like what are the consequences, what are the chances of getting into a problem. One of the problems with MPCs is the corruption risk, right? So there are ways to make the corruption risk either solved or like extremely hard. So we can combine it with like TEEs, to just do the threshold key generation inside TEEs, which makes it like practically impossible to break them, but it adds like, for example, 10% overhead in the computation. Or you can combine it with like things like ZK for verification of the computations, or you can like use like tracing algorithms for like seeing like who is like the validators with misbehaviors and slash them later, right? So there is a lot of theoretical ways, like a lot of tricks, like cryptographic implementations, economic slashing, and everything. They're all possible, but it comes up with the price, with more like complexity, with more like delays. They specifically for the performance part, right? So the way that I see MPCs is that they're like a universe of all options that none of them is like ideal, and they are not going to be like ideal in future for everything. And I think we should carefully allocate the best scheme with the perfect set size of validators, with like most security measures that are relevant for that application, and offer that the optimized solution for each application, for each ecosystem, right? A good example of that, I have like two good examples. Like one example is AWS, right? So AWS is they have like different tiers of servers, right? For 90% of the applications, we don't need like hyper efficient, hyper performance, or like expensive servers, GPUs or TPUs, right? We just run our applications, if not in our local machines, on the AWS server. But for things like fancy algorithms, we may need like GPUs. For things that are like much more like needs like much more security, we may even need air gap systems, or like we may need, I don't know, like TEEs in like CPUs and TEEs together, right? So that's how I see the whole space right now. Like we need, for most applications, like relatively good solutions, but we should also show a way to offer more secure or like more like fancy algorithms in the future. And another example is like simple in more like I think simple example of that is like 2FA, right? For many applications that we currently use, we don't have like 2FA, we don't have like face IDs. It's just like a password, right? Password is just simple like MPC. But if you want to like have your tax account or like very serious like financial accounts, it may make sense to add the 2FA. Like SMS may not be enough. You may have the code generator, you may have the face ID on top of that. So you can add levels of security at the expense of performance, right? And that's like
Yeah.
how I see the whole thing. Yeah.
Yeah, that is a good way to think about it. I think like what you said, how it's like MPC is like a class of technology, like how consensus is, really makes a lot of sense. And how I guess so MPC is like a consensus style, I guess encryption. Is that it? So you need multiple
That's a good
people.
way to describe it. Yeah.
And then ZK is like all like the mathematical algorithm sort of style of, I don't want to say it's like encryption, but it's like a cryptography.
Yeah. Maybe I can explain the three main categories
And
in
then
cryptography.
TEs is
Yeah.
like we'll
Okay.
talk about TEs later. Go.
I don't call T's exactly cryptography, but I'll talk about that later too. I'm not against it. So the three main things that we know inside the inside the crypto ecosystem is like ZKPs, right, and MPCs and FHEs, right. So like quickly touching on them, I don't talk about FHEs like right now, but like they are basically a subset of MPCs for me because of the threshold decryption inside Web3, not outside of Web3. But so the difference between ZKPs and MPCs is that with ZKPs you are like they are completely separate, like they don't have anything like related to each other, right? With ZKPs you can verify ownership of a data or like verify the correctness of your computation as long as the data or the computation is inside your hands, right? So you can prove that you are in the ownership of your own identity, like or a specific data, or like you are satisfying some conditions as long as you have the data yourself and you are seeing it in plain text, right? And then you generate a ZKPs and then they can verify it in a much more simpler way, right? So it doesn't by default have privacies. That's I think like recently there's like some papers that they claim that you have privacy or like confidentiality by default for ZKPs is not necessarily true. Very recently, and but the more important like differentiation here is the multi-party part, right? So if you want to combine private inputs from like a lot of people, for example, in a financial system, right? With ZKPs, you can prove that you've done a transfer, you have like some asset, but you cannot compute over them. You cannot compute, like you cannot combine multiple parties together. Like it's not possible, like theoretically, right? So on the MPC side, you can encrypt something. So like, also like one thing that I forgot is that ZKPs doesn't really like encrypt your transfers. Like even with like things like private transfers, you are basically breaking the link between your assets and other people.
Mm-hmm.
You are not
So
encrypting them. You can see the amount of transactions, right?
yeah. So it's cryptography, but it's not encryption. I think people get
Yeah,
those two mixed up a lot. And
exactly.
so I guess the MPC is more like multiple people that you're trusting versus with ZK, it's like you have to trust yourself. You have to have all this data and then you generate proofs for other people to check.
Yeah, exactly. MPC is actually encryption, but the reason that we are obsessed with like MPCs inside the blockchain ecosystem is that we want to build decentralized systems, right? For a decentralized system, we can't put the decryption key or like encryption key just in the hands of one person. So we have like decentralized mechanisms to perform the whole thing in a decentralized way. It's obviously very complex, very hard, but same as like blockchains in the first place. There is a reason that we are building like Bitcoin and like all of the other blockchains and not like trusting or just like the I don't know, classic TradFi or like just local shops, right? That's the intuition here.
Yeah, and so I guess we'll talk about TEs then. So I guess explain the trusted model and then sort of how that all fits in.
Yeah, I think before that, let me just the way that I see like ZKPs or like TEs and MPCs is like a toolbox. In a toolbox, you have different tools, right? So you can like by default they are solving different problems, right? Like a hammer is not designed for like a screwdriver's task, right? But in some cases, you can combine them for like harder tasks, right? When you combine them, like you can like open like harder doors, right? And this is exactly the case for MPCs and ZKPs or like Ts, because like by default you can run MPCs for like many things, like ZKPs for like ZK identities or like private transfers. But I think the maturity for very complex tasks, for like real private transfers in like 5 years, 10 years without compliance issues, or like for AI, confidential AI, for basically any of these tasks, you should use ZKPs, and like you should also use MPCs. Like they are not going to solve the whole space by themselves. And Tees here is relevant, uh, like pessimistically as a like band-aid solution, but optimistically forever. And they're a hardware solution, right? So we have like different TE technologies. The most popular one is SGX, and there is like recently like other companies like I don't know AMD, like Nvidia, and all of them that are coming with different solutions. Even Intel behind SGX is coming with the new one TDX, and none of them are like somehow like there are differences, but none of them has been into like a lot of experiments. Most of the academia and research like implementations were around SGX so far, and SGX has been broken like hundreds of times in both implementation wise and research times. So I think it's good, like it's trusted for applications that are not that serious, or like some kind of ephemeral kind of privacy. And or like more importantly, I think it's better for combination with MPCs, right? So one way that we use it for the Fairblock, I think probably for the first time with collaboration with Automata Network, is that instead of solely relying on T's and putting everything inside that, uh, or like solely relying on MPCs and risk, like I don't know, hearing the criticism about honest majority assumption. Like one way to actually make that happen while we are waiting for like better MPC algorithms, like tracing algorithms, is just making it extremely hard, right? So the way that it works is that encryption and everything is outside TEs, but the key generation part, the part that people can potentially share their secret shares, that part is inside the TEs, right? So you can think of it as putting your like secrets inside the safe. The safe itself is not like secure, like a lot of people can break it in reality. But if you break the secret and give it to like 20 people, and like the safe technology is different and it's in different houses, it's almost impossible. They haven't solved the problem, but like the attacker should have the determination and the courage to break every local machine and different technologies, and then only after then like orchestrate like a attack with all of these parties, right? And I don't think like 99.99% of the applications has enough financial incentives for such an attack.
Mm-hmm. And so I guess let's talk about also Fairyring. Wait, is it Fairyring or Fairyring?
Yeah, Fairyring is like the mushroom network.
Okay. So Fairyring does not have TEs, right? It's not running, or it is.
So like the current application, that like the current scheme that we have, it doesn't have T's, but we can't, like we already like experimented with that, and if we want to add, it's like very easy, right? So we experimented with our own SGX libraries, also like with automatas, and also with the recent cycles library. Like it was like announced like 2 days ago. And basically, in all of them, like we run the threshold key generation inside the SGX on our validator side, and like verify the attestations on our chain. So it's already done. It's like matter of first like launching, proving the demand and like the traction and everything. And then like once there is a need for like, I don't know, billions of dollars of security and like that kind of things, we can add that, right? I don't believe in very fancy, complex solutions in the first place. I think it's like a iteration path.
Yeah, and so let's say someone wants to use Fairblocks, but like they don't trust TEs. They don't have to, right?
Yeah, like we don't solely trust on T's. It's like the trust is still MPCs. T's is like the 2FA part, right? It's like
you can add it on top. Is that true?
nobody
Or
trusts SMS by default, right? It's a good way to add it to your passwords.
yeah, but so you can also, let's talk about like cycles sort of T sidecar. So let's say you have like a validator set of 100. You don't have to run the TEs on all 100 validators, right? You can have some of them run it, and then if you don't want to run it, you can run your execution, the encryption without it.
Yeah, it depends on your like how you want to use it, right? Obviously, if all of the validators are running inside keys, right, like secret network, I think it's better because um, yeah, obviously, like the more is better. Like all of the validators like should break
Hmm.
that, right? But maybe there's like ways to just have like one TE, right, or like few T's.
Hmm. That's good. And so I guess now let's talk about sort of more deeper applications. Are there sort of a specific? I guess you went through examples. Can you go through like an integration that Fairblock has done, might do?
Yeah, I think we started with DeFi in general, right? So like I call it like protected orders or like intents because for different reasons, like it can be front running protection, it can be like not leaking your scheduled orders, it can be like censorship resistance, or basically like not being hurt by the highest slippage possible. For different reasons, we were working on things like encrypting your orders, and once it's committed and it's going to be executed, we can decrypt and execute that. So it can take different formats, like for example, the way that we have a module for all of the Cosmos chains, or like the way that we are doing that with CowSwap, or like there's like other ways using pre-compose for EVM. But the general flow is like the same. Like we encrypt the transaction once it's committed, we will decrypt and execute it. Even it can work like in future with things like pre-confirmations in Ethereum, because like they can issue the pre-confirmation for the encrypted transaction, and once it's confirmed, we can decrypt and execute it, right? But this the same like flow is the same. Like encrypt on the user side, commit to that, and the network will decrypt and execute it, right? So that's like the first thing that we are started, and we are continuing to work on that as the most serious application for now. So like bad MEV prevention to like and like other kind of front running attacks. And the second part is like auctions, right? So auctions can be has like different ways that can be very meaningful. So the first one is like MEV auctions, right? So in MEV auctions should be sealed bit. So for Flashbots is sealed bit, but it's like a centralized server, right? So I think it's like the centralized servers are like band-aid solutions for a real decentralized mechanism. If we want to build like real decentralized mechanisms, on-chain mechanisms, we should use like threshold decryption, and that's a way to do that. And even for like other parts of the MEV supply chain, like relayers inside Ethereum, relayers are centralized solutions. And like in recent paradigms article, they describe a way that you can use threshold decryption and MPC to replace them. And in some cases, it even makes the system more efficient. And that's like the second part. But auctions has like a very playful side of that. It's not just for mechanism design and other things. It can bring we can be like we've already integrated with like Stargaze, for example, right? With Stargaze, we have like encrypted auctions for like NFTs, right? So like in this phase, like you can get better offers for the bidders. So you can't like shield that. You can't like wait for the last moment by the block proposer and like put the bid on top of that. So it's like a better mechanism, but it also adds like a surprise element to the chain, right? The whole community can bid for an NFT, like a rare NFT, and then like it will be revealed for everyone, right? It's like a mystery box in a sense. And we've also built like games like for Celestia community and Sloth community, for example, like murder mysteries, where like everything is on chain and your suspicion for the murderer is encrypted. Like poker, your next move, your moves are encrypted, and bots or your competitors cannot exploit that, right? That's like that shows us like organically the second category, which is like I call it PvP markets. So in any scenario that there's like multiple people in the set, and you are either competing or you want to hold some kind of information inside your hands before the deadline, even in some cases of betting, like pari mutual bettings, you shouldn't share like what you know like publicly, right? And in those cases, we can build like all kind of like PvP like marketplaces, prediction markets, or like social experiments, and that has like some kind of encryption. And it has like also can be used for like things like randomness generation, because the decryption key can be the source of the randomness generation. And obviously for like access controlling your contents, right? So if it's like a social media, hopefully we have like more active social media scene inside Web3. In that case, they can encrypt it and like monetize the decryption key, right? if someone pays you, you can share like what content you have with them, right? For good or bad purposes. But
Yeah. So the first one was auctions, PvP, and then let's talk.
Sorry for making it too complex.
Go for it.
The first one is DeFi. Let's call it DeFi and auctions, right? For DeFi, but the main application is protecting your orders, because like mostly, in any way, if it's a private transfer, we can do that to make it compliant. But more importantly, for like protecting you from leaking the contents of your transaction and being exploited. So that's the whole category, right? The second category is like more on the PvP markets and other things.
And then let's talk about, I guess, is voting a whole separate category, or does it sort of fit in those two?
Yeah, voting is for me is like the second category in a sense, because like it's like a PvP market like it's not a market, but there's like financial reasons, and like you need to protect your like interactions with other people.
Yeah, can you talk on any sort of projects that are implementing sort of this encrypted voting system?
Yeah, actually, like we got a grant from like Cosmos ecosystem, and it's already ready. So we have a module that can be easily added to any Cosmos chain. And if you add that, you can encrypt your votes. And during the voting period, other people cannot, I don't know, like airdrop you, manipulate it, or like bully you on Twitter, or like wait for the very last second to, I don't know, like to put like another vote and win the whole election. Because we can see that like in many cases it's like 49.9 versus 50.1, right? So I think that that's actually really important in real world, for the same reason we have like ballots, right? And they're not, everything is not in public, but also for ecosystems like Cosmos, where drama per second is very high.
Yeah, I heard the Cosmos Hub was going to add this, or implement it, and I was like, this happened. This happened. So I'm like, yeah, this is a really good use case. And
Yeah,
are there? Go on.
yeah, so other Cosmos chains are also interested. So like Osmosis, like Penumbra, like few other chains like Metasis, like they have expressed their interest for the like voting module. Yeah, that's like some kind of public good.
Yeah, I think that one's like my personal favorite. And I guess, are there any other ones, or sort of any ones you didn't talk about which fit into those other categories?
Yeah, so our focus is on DeFi as a business, but there's also like the gaming kind of applications, if like especially if they're combined with like financial elements, like things like Polymarket. But one thing that is, I think no team has proved like real traction, but it's like we cannot control our intellectual interest in AI, right? So personally, I started my personal path because of cryptography and AI, so like privacy preserving machine learning myself, for both healthcare or like ride hailing applications. So it's interesting that with the recent like I don't know, with recent hypes or like good values around crypto and AI, there's like more and more AI companies in crypto. And I think if we really want to have decentralized AI, confidentiality is like one like very important part of that, right? So if it's about like the supply chain for sharing your data from the user side, the models who are running that, and the end like businesses or like users who want the results, I think that there's like confidentiality element, either because of privacy regulations or because of like monetary like incentives, right? So as a user, you don't really want to share your private information with everyone, right? You just want to share it with like OpenAI's GPU ID, or like some like server on AWS that is running that, right? So we can encrypt it and decrypt it just for that person without any centralized parties involved. And as a business like New York Times data provider, or like other like advertisements or like insurance companies, they want to monetize their data sets. So they can encrypt that and they can monetize the decryption key. So that's like from their side. And from the model provider side, they don't really want to run everything and share the result for everyone. So they can run the model and share the decryption result, share the like ML model's result with everyone, right? So that's one thing that I think confidentiality less is important, specifically around the access control problem, maybe IP problem. And the second thing is confidential compute. So the good example of that is like healthcare, insurance, or like even in DeFi. You want to run models like ML models or any kind of computation to have some kind of statistics or have some kind of decision-making factors from those models, but you don't want to expose like private inputs, right? Individual inputs. So, for example, if you want to run like an ML model on top of your DNA or your traits, like a specific traits, you want an aggregated like result from ChatGPT, but you don't really want to share everything with that company or like on chain, right? So in this case, you can encrypt it. They can run run models on encrypted data without decrypting that. They can't even see the result of the computations, and then we can decrypt the results in a decentralized way. That's like another thing. But also, I think one of the applications that may make sense in AI right now is like on-chain AI agents. So they're basically like bots who are trading for you. And in that case, I think copy trading is a serious problem. So if you can encrypt it like with the same thing that we have for front-running protection or like censorship and others, that we can protect your trades at least until they are not confirmed, right? So other people can, like other bots who are just faster, don't have like better ML models, but they're just faster. They can't front run your like trades, right? For that, or like the same thing, like if we see bots as faster humans, if we need front running protection, censorship assistance for humans, we need like more than that for AI economy.
Yeah, and so all of ChatGPT, whenever you put in your data, I guess other users can see that, or I'm a bit confused on that part.
Yeah, so ChatGPT, like not other users, obviously, because it's a centralized server, right? But you are actually sharing that with the business, right? So the lesson that we have historically learned is that like we can't trust these businesses, like because of privacy reasons or like other security reasons. So we've seen like Facebook or like other, like Facebook is not the worst example. Like we have like much more worse examples, right? And if we want to just share it with them, especially when it comes to serious applications, right? If it's not just for fun, if it's for your healthcare, like you don't know what they can do with your DNA in future. So that's like the trust for businesses, but we are already not trusting their business. That's like the only reason that we are building blockchains, not trusting big tech, right?
But okay, so because ChatGPT is centralized, then you can sort of trust one singular person. But as soon as you put that on chain, now everyone can see it. Is that it?
Yeah. So if you want to share your data on chain, like that's the worst problem, right?
Okay, that explains. I guess so. There are no exactly direct users of Fairyring, right? So they have to use an application, which then uses Fairyring. Is that the correct way of thinking about it?
Fairyring is a chain, right? So the chain, you can build applications on top of that. We already have like 10 applications that people can use on testnet on Fairyring, but we can also connect it to other chains. It's somehow like imported beers and exported beers, right? So if you go to a restaurant, there is like imported beers from that country. They are cheaper, but there is also like I don't know exported beers, right? So we can export our technologies to have like much more like actually like connected to like the user base of like other ecosystems.
Yeah, that was good. Is there anything else you wanted to talk about specifically? Anything I missed? Anything that people don't talk about?
Um, yeah, I think like the question here that like when you talk with other founders and like the community, I think we are having fun with meme coins, right? Like I personally have a lot of meme coins. I love them, but it's kind of sad. Like all of the founders are secretly depressed, other than the $1 million that they're making. But like in the value level, they're a little bit depressed that after 16 years from Bitcoin to now, we've just came up with like better infrastructure just for meme coins, right? So like for internet, the path was much faster. Obviously, there was a lot of technical challenges, but now that we have like all kind of cross-chain transfers, DA, like big blocks and everything, what's like holding us from like serious applications, right? So it may be a matter of time, but I do really believe that confidentiality is like a missing step. Like for like normal users, customers who want a better experience, or just like for the sake of the logic of that application, or like for bigger like banks or like businesses, I think once we have that, it's not going to solve all of the problems like like in that night just by itself. But I think it's like one of the biggest like missing pieces of the puzzle.
Mm-hmm. Let's also talk around. So I guess one of the concerns that people has is that you're trusting a sort of a validator set is sort of like a committee. Could you
Mhm.
talk on sort of like that issue? Is it an issue, one, and then two, sort of how you can like alleviate this, help this?
Yeah, I think trust, like we can always have more trust guarantees, right? But we should be also a little bit practical. Um, so for many application, let's first like talk about the consequences and like what's the trust model here, right? So we have like MPCs. If you don't use like TEEs or like tracing algorithms, which can solve the issue, but the problem here is that there can be like corruption risk, right? So people can work together and like decrypt the transactions, but that's very bad. But the consequences is not losing funds, right? If it happens, like we go back to the current situation where we have like fully public blockchains without like confidentiality. So nothing is going to be lost. I think that's very important to mention because like we are not putting money or like private like keys or like other like so we already have like I think better guarantees than many like for example Cosmos chains with 10 validators, 20 validators that if they work together they can like I don't know steal everything, right?
Mm-hmm.
So that's like important to mention. And secondly, there is like technological ways to solve that. I just talked about T's and tracing algorithms and everything. But thirdly, there is like a way to bring like more economic security. That's the way that we are like working with like things like symbiotic or eigenlayer. That in our own clusters we can have different sizes for the sets, right? So for some applications, just 5 validators is good. For other application, maybe 500 validators, right? And like bringing like more staking, like how like we have different ABSs and which in which like maybe one of them only needs like $20 million of economic security, but the other one needs like I don't know $500 million of security, right? So that's the part that I think like a real engineer or like a real product doesn't go to the highest like I don't know most complex fancy solution with like highest security with like US military guarding the servers, right?
Mm-hmm.
Maybe it's necessary for something, but I think the answer is somewhere in the middle.
Okay. So the trust assumptions for ZK are like you trust yourself and you have like your own data. The trust assumptions for TE is like if you're running Intel, that you trust Intel. Also for TEs, can the sort of validator set that has the TEs, can they sort of share this key? Is that true? Or
Yeah.
they'd have to crack open or something like that?
Okay. So ZKPs by themselves, like even ZKPs, they may have the MPC, so like because in the ceremony part, in some
Mm-hmm.
ZK solutions, if it's like a ZK snark thing, like that's
Uh-huh.
like a trusted ceremony, right? So you're already trusting that model in some ZKP solutions.
Mm-hmm.
But anyways, yeah, with ZKPs is like as long as you're running everything and the ZKP actually has like privacy features, which is not by default these days. That's you and the verifier part, and like trusting the ZKP code because it may have bugs, right?
Mm-hmm.
The T part is that it's a hardware base, right? So there's all kind of side channel attacks, like documented and like real attacks. And if the validator has access to like local T's, there is a lot of ways to break that. Not easy ways, but like possible ways. And
Mm-hmm.
in some cases, even remote calls can make problems. So like not necessarily like local attacks. And yeah, that's the thing. But like not by default, they are not like dangerous, right? The only way to get into them is breaking them. So even the validators should break them, right? But if we have like multiple validators in like an MPC inside T's, you should break like 2/3 of the T's with different technologies. So that's like significantly harder.
Mm-hmm.
And with MPCs is the not by default like we have like it gets like very technical, but we have like honest majority assumption MPCs and we have dishonest majority assumption MPCs, right? So with dishonest majority assumptions, the problem it's like much more secure because even like for example one honest validator is enough. Like you don't need to have like 2/3, right? Something like that. But the problem is that like all of these dishonest majority assumptions are not performant enough for many applications. It's like very complex. So that's why a lot of like practical use cases of MPs is still like honest majority assumption. With honest majority assumption, it's good as long as the corrupted parties are less than a threshold. You can even attribute like trace them even like without any tracing algorithms, right? It's just part of the like commitments, and you can just easily tell and slash them. But if there's like 2/3 of validators or more who are corrupted and working together like secretly, like with an like coordinated attack, in that way they can decrypt all of the transactions and we can detect them, right? And the only way for us to it's like sometimes it's like not a big risk as I mentioned, but the only way to solve that is like tracing algorithms. So like recent Dan Bonus paper and like other papers show us a way to trace misbehaviors of the algorithms. So there's like MPCs and threshold decryption systems that actually doesn't have that problem anymore. You can actually slash them. And yeah, and with TEEs in the meantime, we can make it like almost impossible.
Yeah, that was a really good overview. Let's touch up on the ZK ceremony part because I don't exactly know what ceremonies are. Like there's something like I think Union was doing one.
Yeah,
Are they sort of doing the same or?
yeah, like with Union, like if you run like the ceremony, it was an MPC like library, right? So like with an MPC library, yeah. To be honest, I'm not sure like what MPC library was that, but like basically there's like you're trusting some MPC assumptions anywhere.
And so is that why they encourage a lot of people to sort of participate in the ceremony?
Exactly. The more people that you have in the ceremony, like the bar for the security is higher, right? If it's like 3 people and you have your own share in the ceremony and like you don't delete that after that, you can break the trust of the ZKP is broken, right? But if it's like hundreds of trusted people, it's fine, right? So yeah, in many cases, if it's ZK snarks, we've already have that trust assumption like embedded in our system.
And so I guess we'll talk about that. For those MPC with the ZK proofs to make the ceremony, how much people typically participate inside a ceremony? Like what are the numbers?
I think it's in the range of like hundreds.
And does that affect a performance, or they only do it once? Or explain that.
Yeah, it's only once.
And how hard would it be to do that once with like 1,000 ceremony participants, signers, encryptors?
Yeah, it's not that hard. Like it's like a library that you run, right? And then it's like technical part is pretty easy, but just like you should coordinate it with other people. Like you ask them to do that, like either because they're trusted people, like cryptographers or like other protocols you can trust, or like they're like incentivized party, like maybe your investors or someone.
Yeah. How hard is it from like a computation standpoint?
It's not. It's pretty easy. Like it's like
Okay.
yeah.
And so another thing is that can other people use Fairblock or Fairyring to make these ceremonies? Is that possible?
Yeah, I think we haven't like worked on that yet, but like I think that can be like an interesting use case that we can explore because if it's like MPC, maybe we can do that.
Yeah. Anyways, I think we talked about a lot. Is there anything else you want to specifically talk about that like a huge misconception, something that people don't typically know about Fairblock?
Yeah, I think it's not just about like Fairblock. Maybe I think I can touch base again on the privacy problem. So yeah, whenever we talk about privacy, people just think about Tornado Cash or private transfers, right? So privacy is something about users, like individuals or data, sometimes ideological, right? But I think confidentiality is about systems, like any kind of system that needs to have like data protected for the sake of the logic of the application, right? So it's not ideological anymore, right? So like a good example of that is poker. Like it's we don't hide our hands because of fighting the governments, right? if you want to have like actual businesses with confidentiality in their like logics, or like banks, like normal banks, we have some level of privacy, much more than like current blockchains, unfortunately, right? Um, for that, I think we shouldn't like confuse like a bad example of Tornado Cash with and like seeing the whole category and the technology itself and cryptography or encryption or even working on cryptography projects as a threat. I think the community has panicked and somehow like distracted with like more money on the meme coin side. And the reality is that we have like tons of privacy preserving technologies or like confidentiality schemes, MPC schemes that we are either already using in crypto or outside crypto. Apple has privacy project, like Twitter has privacy technologies. Google is working on like cryptography, FHE, like TEEs, everything. So nobody is going to ban them. Like nobody is going to tell like they're a shady business, right? They understand, right? In the case, so like 99% of the applications of confidentiality doesn't have like zero like regulations challenge in the first place. So zero regulation challenges in the first place. I think nobody gets that for now, unfortunately. That 1%, which is private transfers, is the ZKP solution to break the link. And even for that, you can use MPCs to make it like compliant and like other solutions, right? So you can have pre-checks using ZKPs to prove the source of the funds, and you can also like encrypt them and decrypt them after the fact, right? So TLDR, like privacy is not confidentiality, it's just a subset of that, it's like a feature of that for some applications. And it doesn't necessarily mean jail time or like bad things. It's like one thing that is missing from our industry, and I think it's like fundamental, and we should solve that.
Yeah, that's actually really really good. Typically, when I hear privacy project in crypto, I'm like, are these guys like scared they're going to go to prison or something like that? But yeah, like everyone
Yeah,
has sort of their own technology.
yeah. To be honest, like our projects are the chances of us going to prison. I think like 1% of like
Mhm.
other current projects in the crypto. If anyone is concerned about regulations, I think they should uh, be realistic about the chances of other projects getting in trouble.
Yeah, another thing is that early whenever sort of crypto existed, like everything was transparent and everyone's like, yeah, this is awesome. And then like later on we realized like sometimes it wasn't the transparency that we liked, it was reality like the verifiability.
Mhm.
Could you sort of
Exactly.
talk about that and sort of where the industry is headed?
Yeah, you want to like verify something happening like block in a like decentralized way, right? Like so like you are not just putting the verification power in the hands of one person or like one company, right? But you don't necessarily want to share everything publicly. I think like nobody does that, right? Even if you don't have anything to hide, you don't live in glass houses for a reason, right? Because like it's not a problem about you, it's a problem about like other people, to be honest, right?
Mhm.
uh, this pretty sucks that we are like living in the ecosystem that even the most like decent person, probably like most trusted person, Vitalik, is getting bullied on Twitter because of his donations to science, right? So I'll let it sink there, right?
Mhm.
That's a
Yeah, that's
problem.
good. That is really good. That's like crazy. Is there anything else you want to talk about? Any call to actions to wrap everything up?
No, that's it. That like, and the other point is that the most basic utility of blockchains, which was transfers, is broken. Like you should either
Mhm.
like trust centralized parties and go back to the previous system, pre-Bitcoin era, or you should get into jail, or like or you should like share all of your like payroll and all of your employee information and employers and like your family information with everyone in world. And there is like I think people are using it unfortunately less and less for even transfers. And yeah, let's like hard problems are harder. It takes a lot of thinking and chewing glass, but I think that's like the only way forward.
Yeah, that was good. Thank you for so much for hopping on, and thank you so much for watching.
Thanks a lot. Have a great day.